Alright, so we are looking at 9.3 today. We're going to be exploring the complex plane. If you're following along in these videos, just know these aren't from the notes or anything like that. They're just problems that I made up. So copy the problem down and then we'll kind of solve from there. Alright, so just as a quick reminder, alright, we are in 9.1 we were talking about like regular Cartesian points. Alright, that is like our x comma y. Alright, or where we're on the real axes, right? Like I have this point here, which is, let's say it was 3, 4. So that'd be the point 3 comma 4. And again, that is xy. I could turn that into the polar point, which is r theta. There we go, better. So that is r theta. To find that, I would have to get my r, which would be that distance, and this would be my theta if I wanted polar. Right? However, in 9.3, we are talking about the complex plane with complex numbers or complex points, and so that has the form z is x plus yi. Right, that's how all our complex numbers are going to look. All right. So let's take an example here. Let's say we have the point z is equal to root 3 minus I. Okay. I can graph this on the complex plane. All right. Complex plane. Remember, this is the real part. This is the imaginary. Okay. So in the complex plane, the first number, the one without the I, that's the real piece. And let's see. This is the imaginary. Okay. So with this point, I go root 3 in the positive direction. That'd be somewhere over here. And then I'm going to go minus 1 in the imaginary direction, so it's going to end up going down somewhere. Give me a point here. Okay, so again, that is root 3 and 1. Okay. So this number right here, z equals root 3 minus I, that is a complex rectangular point, we'll call it. Okay. So it's rectangular because it has an x and a y component, x and y. Okay. If I wanted to turn this point into complex polar, right? That means I need to get some r's and I need a theta. Okay, so I'm gonna still use that same picture that we had right here. Well, hey, there's my r. What's my r gonna be? Well, I know that r squared equals root 3 squared plus, oh, that should be a negative 1 squared. So r squared equals 3 plus 1, r squared equals 4. So r equals 2, because I take the square root of both sides. So I get my r, and I need to know my theta. You could find a couple different ones. I'm going to keep it simple. I like our positive ones, so I'm going to go ahead. I'm going to look for the positive angle theta. I know my little reference triangle. This is 1, root 3, and 2. That means it's a 30, 60, 90. This angle is 30 degrees, so that means my theta is 330. Okay. So in order to go from complex rectangular to polar, I'm going to take this point. I'm going to take my equation. Remember, I know that the complex is z equals x plus yi. And I also know some conversions for me. I know that x equals r cosine of theta and y equals r sine of theta. Therefore, I can turn this point, this z equals x plus yi. Remember, this is rectangular. If I want to turn it into polar, I'm going to switch out. I don't want x and y's, I want r's and theta. So that's going to be r cosine of theta plus r sine of theta I. And then, to simplify it, sometimes we rewrite that as we pull that r out. Z equals r times cosine of theta plus I sine of theta. I factored the r out, that GCF of an r out, but I moved the I in front just so we don't forget about it. So cosine plus I theta. So that's how I get bipolar. So back to the problem. How do I turn this equation into polar? Well, I have my r and my theta, so I just need to follow along. So to get it in polar, I'm going to take these, and I'm going to go my z, which was here, or this is rectangular, draw an angle here, to go to complex polar. I'm going to go z is equal to r, my r is 2, cosine of 330 plus I sine of 330. And that is this same point, the exact same point. What looks like here on the imaginary or the complex plane. This is just it in complex. Ooh, can't see it, sorry. Complex polar. This is it in complex rectangular. Alright, so again, the way you find it, once you get it in, when it's in rectangular, you want to find your r and your theta. And then we use this conversion idea between the two. Get r cosine theta plus r sine theta I. Or you can factor it out to have this little abbreviation. Alright? So these are the exact same spots, just two different ways to describe it. Two different ways to tell you the orientation or the position of that point. Alright? Let's look at one more. Okay. Let's look at the complex number z equals negative 3i. So again, I'm going to draw it. I have, this is like saying z equals 0 minus 3i. So I am 0 in the real direction, down 3 in the imaginary. So 0 in the real, down 3 in the imaginary. I'm down here at this point. So if I want to go to polar, I need r's and thetas. So my r, that's the distance from the pole. It's just 3. And then my theta, well, hey, what's the angle? What's this angle here? Boom. 270 degrees. All right, so to convert, remember I had that formula. I said, hey, z, if I want it in polar, it is r times cosine of theta plus I sine of theta. So z equals r, my r is 3, cosine of 270 plus I sine of 270. Right. So that is it in polar. Now, there is sometimes that abbreviation, that cis abbreviation. If your teacher showed you that, you could rewrite this in that cis. It would just be z equals 3 cis 270 degrees. If your teacher had not shown you it, don't worry about it. This is totally fine. Okay. Now, I want to show you one more piece. The question is, do you believe me that this is the same point as this? Well, we can go ahead and take it. So I'm going to see, is z equal to negative 3i? Is that the same as z equals 3 cosine of 270 plus I sine of 270? So, to determine, I'm just going to evaluate. Actually, we'll come back to this to see. This is what the next video is going to be on. All right?